Hello everyone, welcome to TechBuddy. In today's video, I'm going to be talking about delegate and you're going to know what it is and how to use it, or if you have ever used it. It is something that we mostly use behind the scene, but it is always good to know what is happening behind the scene, right? It is exciting. So let me dive into what is delegate and how we define it and how we use it. Let's dive into it. Delegates basically are, it is difficult to see, but I just need to show what it is. So we just forget about the delegates, and let's say we have a variable x and its value is 1, and we have y and its value is, let's say 2, but maybe x plus 2. Right, and we can have something string name, and it can hold the value of Sally or reference of Sally. So on here, I can say on the screen, I have an integer value x and integer value y. X value is 1. I'm saying value is because it is a value type. It's not a reference type. What it does is basically it is holding the value of 1 here. What y does is holding the value on the equal right hand side of equal, which is 1 plus 2, 3, right? Basically, if it is a reference type as a string, for example, it can hold the reference of the value on the right hand side. What I mean is, in the memory side, we have stack and heap. The reference type are always kept on the heap side. As string is a reference type here, the value of Sally is kept on the heap side, but the variable name, the name variable, holding the reference of the point of the location where the Sally value is held on the memory on the heap side, right? So if it's a value type, it's holding the value. If it is a reference type, it's holding the reference of the value again. So if it is a class, again, it is holding your value. Your variable is going to hold the reference of where the class is actually held on the heap side. Delegates are similar, but not 100%, is because delegates are holding the reference of any function, not the value of your variable, like Sally. It is not holding the actual value, just like 1 or 3 or whatever it is. It is basically holding a function, reference of function. If you access that variable, that means you access that function. It is the same. If I print this name, I'm basically accessing the value. So I'm basically going to heap side, find the value, and use it. It is the same for delegates. Delegates are holding the functions or methods. I'm just going to explain what they are. It's holding the function, the reference of function. Whenever I call it, it knows it's going to bring me the whole function. I'm going to do whatever I do, right? So this is string and integer. Delegates are, as I just said, holding the function. But we have function structure. We have a structure. We are defining a function with some property name, some specific keyword, some specific pattern, which is we have access modifiers, right? So we have private, we have public, we have internal, we have protected, whatever it is. If you don't put anything, which means it is private. So what I will say, okay, private, and then it is followed by the return type. Not all function returns anything, but so basically function is returning something in SQL Server or in C# basically, but methods are holding everything. It could be procedure or function, but I'm gonna call everything as a function. It's because in C#, if method is not returning something, you say void, but it is a sort of reference type, return type. So if it doesn't return anything, means it returns void. So instead of method, I'm going to call everything as function in C# in this video. So we have return type and we have the name, let's say get name, right? And we have brackets over here. If inside of the bracket is filled up like an integer last name, maybe the name is maybe full name, it passed me string last name, and I return something then, Sally plus last name, for example, but this function is defined as not returning anything. But if it was a string, for example, I could basically return something. So we can have different sort of functions, right? It can accept parameters, or it doesn't have to maybe. It cannot, maybe it's just gonna return a value. If it is void, it doesn't have to return anything. Maybe it should just console write line anything. It just does something, doesn't return anything, but again, returning void. So this is the structure of function. So functions could be different and it could vary, right? If I said delegates are holding a reference of any function, how do we define that? So let me just show how we define it. So delegates are basically, to define a delegates, we need to define our own type. What I said is, delegates can hold reference of function, but if we have different type of functions, that means we can have different type of delegates, right? So I'm gonna say, okay, delegate is my keyword here. Delegate is followed by what it is going to return. So it's gonna hold a function, but function returns something. If it returns void, I can say, okay, this delegate can hold all functions that returns void. Okay, so string return action delegate. This is what I said. Okay, this is my definition of delegate. What it does, actually, it says to C# compilers, this delegate can hold any function. The name doesn't matter. The name belong to delegate, not the function. This delegate says to C#, okay, whatever function you have that returns void, except no parameters, is because the bracket is empty. It returns void. I can hold its reference in that delegate, it says. So I have one here. So get full name, right? Maybe I'll say print full name. Print full name function is a function. So delegate is returning void. So this delegate can hold this one, I can say. Let me try. So get rid of this one. So delegate is a type, right? So I need to have a variable to hold the reference. It is the same for string. For example, if I had a string type, it's a type, and now I'm creating name property, name variable, and having something on the right hand side, it's going to be the same for delegate. I have my delegate, which is string return action delegate here, and I say, okay, it is really, let me just get rid of this ig parts, make it del, and it is basically string del. I'll just say, okay, this string del is the type of that I'm gonna have a reference for. My reference is that string action del, right? And left hand of the side, the equal, is holding a delegate. Right hand side of the equal should be the same, so the type matches. What I said is this delegate can hold any function returning void. So in this case, right hand side is something that returns void. Left hand side is something returning void. I mean, not returning void, but can hold a function that returns void. In that case, my delegate, my reference of this function is held by this variable. So whenever I go to this variable and say, okay, whatever you have, whatever you are holding the reference for, I know it as function because of my type, just invoke it. That means if you access that name, it brings you the Salih, value of Salih. So you can use the Salih everywhere you like. The delegate returns the function itself, the print full name. So you can invoke it without knowing what is inside. It really doesn't matter. So if I call this one into a string, into right line, you're gonna have the exception over here. The ID is going to get angry. It's because it is not returning anything. If I hover the mouse, it says void, right? So it doesn't return anything. So instead of having it here, I already have it there. So if I run that application by building it, it's gonna print out this Salih Kantekin. That's because I invoked it. So you see the Salih Kantekin here. Okay, delegate can hold everything. I mean, everything X, as long as it matches its type. So its type was void. But we could have different ones, right? So it could be, for example, string get full name, right? This is my function. I'm having a new function here that returns something now. So for different types of functions, I can have different type of delegate, right? So my delegate this time is going to have a function inside that not returns void but returns string, right? So this name is wrong actually. It doesn't return anything. You didn't tell me I made it wrong. So I'll just say an action delegate, right? It's because now this is string returns delegates. Ooh. So this string return delegates now can hold a function that returns a string, just like the over here. Let me rename that to action del. And this could be string del. And the right-hand side could be get full name, right? The right-hand side is a point, the reference, the functions itself. And left-hand side is the variable is holding the reference of that function. So everything is good. So I can again say, okay, invoke. But this time, as you see, it returns something. It returns something. So I can print this too. I'll just, yeah. So again, Salih Kentakin, which is the full name, I invoked it and it returned me something and I was able to print this. So different types of string, different types of delegates, even though I could have delegate returns string, but also string returns p delegate. So in here, I'm just going to say, okay, p1. This is another type of delegate. It says, okay, this delegate can hold any reference of any function that returns string, but also accepts a string parameter. So let me give you an example with that. Again, just get rid of those. This is, let's say, S1 and new. Let's have a, by the way, let's have a function get full name. It accepts a last name maybe and returns Salih plus last name. So this is another function. Now I'll say this delegate, full name combined, let's say. No, this delegate is going to hold a reference for a function that returns string like that, but also accept one string. So to invoke that one, now if I go to invoke function, it says, okay, I'm going to return you a string. Invoke. I'm going to return you a string, but you're going to pass me another string. So if I say Kentekin and print this out from the application, it's again, I see Salih Kentekin. It is the only one that I wrote, right? So this is the delegate. What I'm going to show you is totally different. Maybe you never get into the code, but you might be surprised. So if I say I have a function delegate, if I have a delegate that returns void, I should be able to invoke any function. I should be able to hold any function's reference within that one, right? So the action delegate. I'm now going to get rid of everything I have here. I'll say, okay, action delegate. It can hold any function that returns void. So I'll have a void print 1, let's say. It does nothing. Maybe it does nothing. So I can have it here, right? This is a perfect validation. This is the perfect condition that I can just hold here. What if I have P2, P3, P4, and those functions, let me just do something, console, write line, name of print 1, but it is print 2, print 3, print 4. So every function is going to print its name, right? So if I say action is going to hold print 1, but also I want to say it can hold print 2, but also say can 3 can hold the 4. So as I assign this one at last, if I invoke this one, let me invoke that. If I invoke that one, I want to see, I would probably be seeing that print 4 name, right? So let me run it. I run it and print 4. So In my project, in my C#, in my framework, it doesn't matter. I can have a general delegate like that, and it can hold any function that returns void, and I can use it everywhere, right? Surprisingly, we already have one. I'm not sure if you have ever used that action here. Action is the class. For example, it could be generic as well. I can say, okay, this is my action. It could be a variable, action variable, right? On the right-hand side, it says, okay, it accepts an integer parameter and do something. Maybe also write line the P. It doesn't matter. So this is, I can get rid of this one as well. So this is the variable on the left-hand side of the equal, the variable that holds something that function that accepts P parameter and do something. I don't have to have it here, then I wouldn't have it here, and I wouldn't have it here. That still works. On the right-hand side, the equal does something. So it is an action. It is something that I can call, I can invoke, that returns void. On the left-hand side is the action. Do you know what action is? If we go into that one, so we have delegates in C#. It is predefined. It is built-in delegate C# in framework that holds void returning functions. So we can have that. We already have that one. Surprisingly, we have more. So as this could be an integer, for example, or string, it doesn't matter, but it says in, which means it can, so this action can only have function. I mean, the parameter, sorry. So if I say string here, that means this action parameter should be string. So CTR, for example. But if you want to return something from that function, so this is printing and it's not returning something. If you want to print something, I mean, if you want to return something, not void, but string maybe, then you cannot use the action. It's because the delegate of action, for example, for the generic type says, okay, this T type is only in, so it could be only parameter. But if you want to return something, we have another type, which is func. It is the same. So the first parameter is out this time. So which means if you say integer, and if you want to hold something, a reference of any function, that function returns an integer, right? So if I have a function that returns an integer, let's say integer get user ID here, and it returns 1, maybe. Let me get this true here, right? So get user ID. Now this func and int return func, let's say, and on the right-hand side, I should be able to assign my get user ID function into that one, right? Int return func, whenever I invoke that, for example, see, it returns anything. So func can also hold the parameter as well. Get rid of those. What I mean is func, if you go to the generic side, the first parameter is out, but also if you go down, it says, okay, I can accept one in, so you can pass me a parameter and I can return something. So if I say, okay, accept integer parameter and return something integer, so func return int, I can say, now I can have it here. So my int parameter here, but also this has to return, let's say, p times 2. And it is another function, right? So the right-hand side is another function. I can have my function within this shape or inline function within this shape. So I'm holding this once. Now, if I call the invoke function, it says, okay, I'm going to return you an integer, and also I'll accept an integer. So this is a perfect scenario for it. What is surprising for delegates are, in, let's say, X, we can have one value on it, right? So once this run is executed, when this line is executed, X can only have 10. If I say X is 5 here, when this line is executed, X value is going to be changed and the new value will be 5. It is not the same for delegates. By the way, if I go to function Again, I will see it is a delegate that returns a generic type. Also, the out parameter, I mean, what it returns is also the generic. So it is not different than I would have over here and create mine, but we have already have those delegates built in C# and in framework, actually. This is the side note. What is surprising for delegate is that it can hold multiple reference. So what I mean is that, so get me rid of those functions. So this function, right, action variable, on the right hand side, it prints, okay, no param. I mean, actually, yeah, action, no parameter. So once this is invoked, this is what's going to happen, right? It's going to print no param. Within that one, I can have print 1, right? I'm just going to get rid of those. Actually, this action doesn't have to be that action, but I can use mine as long as the pattern matches. I'm going to get rid of those, right? So now I'm having this one and also this one, but we've done that example. So whatever I set the last, it runs. I've seen it. So if I run this one, for example, it's going to print 1. It has to be, I didn't invoke it. Invoke. So if I run this one, I see print 1 over here. It's not a surprise. What surprise is, instead of assigning the value, I can say, okay, I am now adding you, whatever I have, now I'm adding something new. So this is basically a stack, a queue of, or collection of the references of functions that it can hold. Multiple function it can hold and invoke at the same time. So I assigned this one first, and then I assigned this one. So now I would expect to see is both. So no param and print 1. And I also can do it for 2, for 3, for 4. 99.99 times probably it's gonna print, it's gonna execute the function that is being in order that it's been added. So if you add this one, then that means it's gonna be run first one. And this one will be executed on the second time, and this one will be invoked in the third time, and this one will be the fifth. If I run this, for example, you will see print 1, 2, 3, 4. I said 99.99 times. It's because Microsoft Documents doesn't say it is guaranteed that it's going to be invoked in order that you've added. So it could be even different. So delegates basically can hold a reference, but not a single reference. It can only hold multi-reference of any function. The function and the delegate type should be matched, should match. So in here, I have void returning function. I can use this one for anything. It really doesn't matter. This one accepting a function that returns string. This one accepting a function that returns string, not only returns string, but also accept string functions, string parameter. So those delegates can be defined by you, or you can use generic ones in C# with action. It could be generic. So if you go down, you would see 9, 11, 12, 13, 14, 15, 16. That's all, 16. What if you have 17 parameters? In that case, you cannot use the action. For the function accepts, it says, okay, I'm going to return a string value, I mean the generic type over here out. But if you go down further, 10, 15, 16, 17 on the 17 line, 17 overloaded. Yeah, 17 overloaded function. It says, okay, in, right, a function, any function can return only one thing. If it is not a tuple or if it is not a value type, it doesn't matter, but can accept 16 parameter. What if you're going to need a function that accepts 17 parameters? In that case, you're not going to be able to use it. So if you go in function, you would have 1. But if you say, okay, my function, let's say integer, so to 5 parameters, integer parameters, and return something, let's say string again. For example, if you go within that function, it's also predefined. right? So you can go and find the function that accepts 16 parameter and return something 1. Or again, the same action can 16 parameter can be referenced to it, but for the 17 and for I don't know who is gonna need that, who's ever gonna need that, but it is something. So delegates are basically holding a reference of function, but as the function could vary, so the name, return type, and the parameter, the name of, not the name parameter, but type of the parameters could be different. The return type could be different. As you might have different sort of function, you can have different sort of delegates. You can either use the predefined one or you can use your ones. So from that video, it's been already 20 something minutes. Probably I'm going to cut somewhere with 20 something minutes. It is still long for that function, that video, that feature in C# we have. I hope you liked it. If you liked it, please hit the like button. And if you want to see more videos, make sure that you subscribe and turn on the notification bell. Click the notification bell. Until next video, happy coding.